Okay, today for section 7.1. So we just spent a few days doing proportions in section 7.3. So now what we're going to do is we're going to switch over and we're going to talk about how to find averages. There are actually two ways to deal with averages. The first is if we know our population standard deviation. So if we know our population standard deviation, which is sigma, right? Then we use z-stars. It is going to be extremely similar to proportions. We're just talking about averages now, the average number of people, the average amount of money, the average number of colleges you apply to, the average number, it's averages, not percentages. If that happens, then what's gonna go on is we're gonna have mu in the middle, okay? You're gonna have the same three z-stars that we dealt with last time, but it's gonna be x bar, your sample mean, plus or minus z-star, your population standard deviation over the square root of n. Note this time the square root is just in the bottom, okay? A really good rounding rule is to round off to one more decimal place than the number of decimal places in the original data. So we're just gonna kind of jump right into the problems. Example 1, a researcher wishes to estimate the average amount of money, so indicator of that we're switching to this kind of problem. The average amount of money a person spends on lottery tickets each month. A sample of 50 people who play the lottery found the mean to be $19. Okay, so the sample mean was $19. If your population standard deviation is 6.8, next section I'm going to talk to you about if it's a sample standard deviation, but today we're doing population standard deviation. Find, first off, your best point estimate. What's one point that we could best estimate? We actually had tackled that at the beginning of the very first lesson we had. That's equal to your sample mean, $19. That's our best guess. Our best point estimate you might want to jot down as your best guess. Our best guess is our sample mean. Okay. Now, if we want to do 90% confident, we're going to use our z-star for 90%. So again, use your formula. It goes x bar minus z-star, parentheses, standard deviation, over the square root of n, less than mu, less than. We're going to do the same thing on the right, but we're going to write plus 1.645 times 6.8 over root 50. Yeah. Okay, if you grab your calculator, we're going to have 19 minus 1.645 times 6.8 divided by the square root of 50. We're going to get 17.418. Less than, we're going to do the same thing on the right, but we're going to change this minus sign to a plus. 20.582. Okay, if we were to interpret, this doesn't say interpret, but we should also talk about how to interpret it. It would be, we can be 90% certain that the true average amount of money spent on lottery tickets per month is between $17.418 and 20.582. Okay. So if it says 95%, we're going to have the same basic setup, but we're going to change our z-star. Okay, so we're going to have 19 minus 1.96 times 6.8 over root 50. Less than mu, less than. I'm okay, hopefully at this point, and I bet we've talked about this in class by now. Like, they're the same things, just the minus and the plus. As long as you write it out nicely once, thoroughly once, okay? And I'm okay if you just put a plus sign on the other side, because at this point, hopefully, if you've done all your practice, you know that this matches this, just the minus and the plus. All right, when you throw this in your, go ahead, try, come on, you gotta make sure you practice, right? You're gonna get 17.115 to 20.885. Okay, and you know what? Let's just change this. Let's change our round off, be round to 3 decimal places, just like we did with proportions, so that way we're nice and consistent. Okay, so just let's change that. Let's make it round to 3 decimal places. Okay, 99% confidence, right? Oh, and your interpretation would be the same sentence. You're just going to swap out 90 to 95, and you're going to change these numbers to these numbers. Okay, 99% confidence, you'd have the same setup, but we're going to go move on up to 2.58. 6.8 over root 50, less than mu, less than, switch it over to here. Now guys, this is also important. You're not dealing with a proportion, so you can't put p here, right? It's mu, it's your population mean. We're trying to estimate the population mean. So if you put p here, you're talking about a percentage, which is not an average. Okay, this guy should give us 16.519 up to 21.481. And that would be your interval here. Okay, so we just did the same problem. We again can see like this is the narrowest because we're the least confident. The more confident you get, if you leave all the other numbers the same, right? The sample size, the mean, the sample mean, the standard deviation, then you're going to get a wider interval the more confident you get, because your critical value, your z star, is increasing, right? The bigger your multiplier, the wider your interval gets. So why don't we tackle this guy? All right. A survey of 30 adults found that the mean age, so n equals 30, the mean age of a person's primary vehicle is 5.6 years. So our sample mean of 30 people came up with an average of 5.6 years old. Assuming the population standard deviation is 0.8 years, we want to find and interpret the 99% interval. So 99% means that your z star is going to be 2.58. Okay, so go ahead, try to set it up, right? You're going to get x bar minus z star, standard deviation, over root n, less than mu, less than, same thing on the right, but it's going to be an addition. Okay. So then you're going to plug this in your calculator. You're going to check to make sure that you can actually get the right answer when you type them in. Okay. And you should be getting 5.223 up to 5.977. All right. So that's find. Now interpret. How are you going to, so we did the find. Now we need to do the interpret. When you interpret your interval, you get what? What do you get? Okay. We can be 95%, or we are, or 99, I apologize, I misspoke. 99% certain, or confident, or sure, however you want to do it, that the true mean age of primary vehicles, that's like your everyday car, right? Not the fancy one that sits in the garage or the hunk of junk that sits in the driveway, right? We're talking about your main primary everyday driver, okay, is between 5.223 and 5.977 years. All right. Now, what we haven't done is we haven't talked about margin of error yet, which is also what this question asks. What's the margin of error? So if you think about it, just like last time with proportions, p hat was right in the middle. So your x bar, your 5.6, is going to be right in the middle. So when you go to find your margin of error, take the top number and subtract your x bar. And you'll get 0.377 years. Okay. Now, this doesn't have to be less than 1, right? Because means can be higher or lower. It just happens to be less than a year, but it could be the other way. All right, so we know how to find the interval. We know how to interpret the interval. We know how to find the margin of error. So just like with proportions, but this time, since we've been working on this so long, hopefully we're ready to rock and roll with this, right? We're also going to talk about how big of a sample size do you need? What's your minimum sample size needed? So when it says find your minimum sample size, that means find n. So the same exact idea, we're going to have n equals same z stars times sigma over e, your error of estimate or your margin of error, and we're going to square it. Okay? So If we want to estimate the average age of students at a college, 99% confidence is desired, which means Z-star is going to be 2.58. The standard deviation is known to be 3 years. How large a sample is necessary? So you might want to put a little star. That means find N if the average age should be accurate within 1 year. So if our standard deviation is 3 years, accurate within 1 year means E equals 1. So we're going to have N equals Z star times sigma over E squared. Okay, it's that whole thing. So when you put this in your calculator, let's go. So we're going to have 2.58 times 3. I didn't put divided by 1. Well, we could, right? But we don't really need to because it's 1. And then we're going to come outside the parentheses and we're going to square it. We're going to get 59.9. Same exact idea. We always round up to the next whole number, no matter what that decimal was. So 59.9 goes up to 60 students. But think about it. 1 year is a lot of wiggle room if you're talking about kids at college. A year above or a year below, when you're talking about a 5-year window, is really big. But you're not going to be really accurate, so you don't need to ask a lot of students. Now, if it's accurate within half a year, be careful. That means that E equals 0.5. So now we're going to have the same exact numerator, but we're going to have 0.5 squared. So this is where you need to do parentheses, and inside the parentheses you need to start your fraction, and you're going to have 2.58, oh no, can you read this? That's probably better, times 3 over 0.5, then go to the right till you get outside the parenthesis and hit the square key, so it's the whole parenthesis being squared. Now, if we want to be accurate within half a year, we need to poll 240 students. Okay, if we talk about the average age accurate within 3 months, E is equal to what? 0.25. Be careful. If your standard deviation is in years, then we need to be consistent, all in the same units. Years, years, years. So 3 months is a quarter of a year. All right, so 0.25. So we're going to have N equals 2.58 times 3 over 0.25 squared. And when you put that in your calculator, you get a lot. You get 959 students. That's a big sample size. However, you want to be really accurate. You want to be within a quarter of a year above or below the truth. That's a narrow interval that we want. So we need to poll a lot of students in order to accurately answer that. Okay? So what I'd like you guys to do right now is I'd like you to now think about example 4. And now's a great time to pause it, try this on your own, and check back against me, right? A researcher is interested in estimating the average monthly salary of news reporters in a large city. Standard deviation is 1,100. We want to be accurate within 150. But this time, we're going to change our confidence. Okay, so we're going to have N equals 1.645 times 1,100 over 150 squared. Okay, versus 95% would be 1.96 times 1,100 over E, versus 99% would be 2.58 times 1,100 over 150. So in example 3, I manipulated the accurate within our margin of error each time. This time we're manipulating our confidence level. We're keeping our accurate consistent, but let's think about it. The more confident you want to be, what's going to happen to your sample size? It's going to increase, right? Because if you want to be confident in your answer, you need to ask more people. The more people you ask, the more certain you are about how right or wrong you are. So this one comes out to be 146. Type them in, check to make sure you get the same answer as me. This guy comes out to be 207. This guy comes out to be 358. So yeah, if you want to be 99% confident instead of 90% confident, you're going to ask more than double a sample size. And that should make sense because we're going to cruise through that. All right, the more you ask, the better your answer is, so the more confident you can be in your answer. Now, example 5, a statistician collected a sample of college students and asked them how many hours a week they spend doing work or studying for their classes. This is actually the same beginning as our example like this in section 7.3, our first section. However, now I'm changing it. It's going to be, I found the 95% confidence interval for the average number of hours to be. So we're going to have our average is 28.8 up to 40.2. We have 95% confident, which means Z star is equal to 1.96. We need to get to N equals Z star times standard deviation over E. Now, I made a mistake, okay? And my mistake is that I forgot to give you, I forgot to give you your standard deviation in the problem. So I'm going to, it should be typed in here, and we should know that sigma equals 15. Okay, so I'm telling you that should have been written in the problem, and I forgot to do that. I apologize. So if your standard deviation is 15, what we need to figure out, right, so now we've got our Z star. We've got our 15. We just need to use this interval to come up with our margin of error, okay? Now, to find our margin of error, we know that our sample average is going to be right in the middle. Do you agree? So how many do we go up and down from our sample average, right? What's the middle number? Okay, the middle number, now what you could do is you can add these together and divide by 2. You do an average to get the average number. The average number is 34.5. So now from 34.5, our margin of error is how much you go up and how much you go down. So we could say, hey, well, the same way we've done before, take the top number, subtract the sample mean, and that's going to leave us with 5.7 as our margin of error. Okay, E, ME, it doesn't matter which one you call it. So that 5.7 goes here. So if our 5.7 goes here, we're going to plug this in our calculator. Don't forget the square power. People love to forget that. And we get N equals 27 students. And that's our answer. Okay, so great job today. Way to take good notes. Of course, we will practice. And let me know. Write down. If you have questions as you're working through, calculator problems, notes problems, jot it down, let me know, and then we'll touch base.